So we need to find the derivative of the function f of x is equal to the natural log of 1 plus e to the x over 1 minus e to the x. So what I'm going to do here is I'm going to split this guy up using my log rules. So this is going to be the natural log of 1 plus e to the x minus the natural log of 1 minus e to the x. Now what I'm going to do here is, and I can't distribute this natural log in, it'd be nice if I could, but I can't. So what I'm going to do, I'm going to use the following. I'm just going to write this out as this. Okay, I'm applying all the steps here. I'm showing you everything so that there's no gaps. Okay, and you should, when you're working on homework, whatever you're doing, you should show all pieces to make sure that your solution is not just a solution, but it goes ahead and proves to the reader that every step is correct. Okay, so we'll distribute this guy in here. Like that. This guy right here, I'm going to let the following. I'm going to say first that, we'll use a different color here, we'll see. Oops, I thought I grabbed a different color. Okay, u is equal to 1 plus e to the x. So that means, and then let's also let v equal 1 minus e to the x. So here's what I've really got here. I've got d over dx of the natural log of u minus d over dx the natural log of v. So I'm going to do some substituting here. This is du dx times d over du of the natural log of u. And this is going to be minus dv over dx times d over dv, or the derivative with respect to v of the natural log of v. So over here, this is going to be du dx times. Now the natural log of u, the derivative of that with respect to u working backward, is 1 over u. So this is minus dv dx. Now the derivative of this is 1 over v. So let's go back up here now and do some calculations. Du dx is a derivative of this guy, which is d over dx of 1 plus e to the x, and the derivative of that guy is d over dx of 1 plus d over dx of e to the x, and that of course is just e to the x. So down here, this is e to the x times 1 over. So 1 over u is 1 plus e to the x. So let's go ahead and insert that in there. So this is 1 plus e to the x. Now this is going to be minus. Now d v dx is equal to d over dx of 1 minus e to the x, which is d dx of 1 minus d dx of e to the x, which is going to be 0, minus e to the x. So negative e to the x. So this is going to be negative e to the x times 1 over v, which is 1 minus e to the x. So this is going to be e to the x over 1 plus e to the x minus a negative is positive, so plus e to the x over 1 minus e to the x. Now if we want to go a little bit further here, we can get a common denominator and put these guys together. So this is pretty good right here. Okay, but let's just continue this. So we've got e to the x minus e to the x times e to the x, which is e to the x squared, or e to the 2x. So here's what this is going to be e to the x times e to the x, which is e to the x plus x, or e to the 2x, plus 1 times e to the x is e to the x, plus e to the 2x. And this whole guy is over this thing multiplied out. So this is going to be 1 times 1, which is 1, so I'm foiling this. The middle terms are going to cancel out. I'm going to be left with minus e to the x times e to the x, so minus e to the 2x. So notice that up top here, this guy and this guy cancel out, and so I'm just left with 2e to the x over 1 minus e to the 2x. Let's go ahead and check to see how our computer program would do that. So let's slide back up to the top so you can see this. So I want the derivative of the natural log of the quantity 1 plus e to the x divided by 1 minus e to the x. Okay, so here's what we've got for a solution. It's actually rather, oops, because I put the equal sign in there. There we go. That should make it turn out a little bit better. So we have 2 times e to the x over e to the 2x minus 1. Okay, so I seem to be reversed here. Let me check out why. I see. If you go ahead and you look here, they've pulled out a negative. So if I take this negative and I multiply it back through, I'd have 1 minus e to the 2x, which is exactly what I've got here.